There's a video of a leopard standing over a baby baboon in the middle of the night. The baboon's mother is dead. By every rule of nature, this is a 2-second snack. Instead, the leopard picks the baby up gently in her mouth, carries it into a tree, and keeps it warm against her body until morning. She doesn't eat it. She protects it for hours. And nobody has a clean explanation for why. This isn't a one-off. Somewhere right now, a house cat is nursing a duckling. A German shepherd is grooming a kitten it didn't give birth to. A pod of dolphins is slowing down to swim alongside an injured seal pup that, on any other day, would have been lunch. Something in the animal brain looks at a baby, any baby, sometimes not even from its own species, and flips a switch. The predator stands down. The rules change. So what is that switch? And why does it work on creatures that have no business caring at all? In 1943, an Austrian zoologist named Konrad Lorenz noticed something strange while studying animal behavior. He found that certain physical features, a big head relative to the body, large, low-set eyes, round, chubby cheeks, short, stubby limbs, triggered an automatic caretaking response in adult animals. He called it Schema, baby schema. It wasn't specific to any one species. It was a shape, a set of proportions. And whenever that shape showed up, something ancient in the observer's brain responded before thought even entered the picture. Lorenz's theory sounds almost too simple. A shape triggers a feeling. But decades of research since then have backed him up in ways he probably didn't expect. Brain scans on humans show that looking at baby-shaped faces, round, big-eyed, small-nosed, lights up the same reward circuits as looking at food or money. Not metaphorically. Literally the same neural pathway. Which raises an uncomfortable question. If this response is just pattern recognition, a shape detector wired into the brain millions of years before language or logic existed, then maybe it was never really about your species at all. Maybe it was about the pattern. And patterns don't check ID. That would explain the leopard. It would also explain what happened in 2007 near a river in Kenya, when a lioness was filmed adopting an orphaned baby oryx, a species lions hunt constantly. She let it nurse against her side. She walked with it. She fought off a male lion that tried to attack it. For over a week. Eventually the calf wandered off on its own, and researchers who studied the footage couldn't find a survival reason for any of it. No food benefit, no protection benefit for the lioness. Just an animal responding to a shape it was never supposed to care about. Here's where it gets complicated though, because if this really is just a hardwired reflex, it should misfire constantly and predictably in the same direction. But it doesn't always. Plenty of predators walk straight past baby prey animals without a flicker of hesitation. A crocodile doesn't pause at a baby zebra. A shark doesn't spare a seal pup out of tenderness. So the switch isn't universal. It's selective. And nobody fully understands the rule for when it fires and when it doesn't. One theory is that it comes down to how closely the young animal's features match the exaggerated proportions Lorenz described. The rounder the head, the bigger the eyes relative to the face, the more likely the response triggers, regardless of species. A baby oryx, with its oversized eyes and short legs, might simply look more baby to a lion's brain than, say, a baby crocodile ever could. Under this theory, it's not about kinship or empathy at all. It's pure geometry. The animal isn't recognizing a fellow creature. It's recognizing a shape category and reacting to the category. A second theory points somewhere completely different: social cost. Researchers studying wolf packs and elephant herds have noted that animals living in complex social groups seem to show far more cross-species tolerance toward young animals than solitary hunters do. The idea is that in an ecosystem where multiple species constantly interact, sharing water sources, overlapping territory, competing for the same space, constant hostility toward every vulnerable young animal you encounter would be exhausting and dangerous. An individual that reserves aggression for genuine threats, rather than triggering on every small, defenseless creature it meets, spends less energy fighting and survives longer. Under this theory, sparing the baby isn't tenderness, it's efficiency. And then there's a third, stranger idea, one that a growing number of behavioral scientists take seriously, that the response isn't a bug in the system at all, but something closer to a feature that never got switched off. The circuit that makes a mother care for her own newborn is ancient, hundreds of millions of years old in mammals alone. It evolved before brains were sophisticated enough to reliably tell my offspring apart from offspring, generally. So the signal that fires is blunt. Round head, big eyes, small body, distress call. Fire the caretaking response. The brain never developed a precise filter for whose baby it is, because for most of evolutionary history, it never needed one. You lived, hunted, and raised young almost entirely around your own kind. Cross-species contact was rare enough that a sloppy filter never got selected against. Under any of these three theories, humans are the strangest case of all. We haven't just tolerated the young of other species, we've built entire relationships around it. People have raised wolves, bears, big cats, and birds from infancy, animals that every survival instinct says should be incompatible with human closeness. And it isn't always one-directional. There are documented cases of grown bears raised as cubs and released back into the wild, returning years later and recognizing the humans who raised them, nuzzling them, leaning into them, behaving nothing like the food-driven animal a purely instinctual theory would predict. If baby schema were only about getting something out of the relationship, that recognition shouldn't outlast the need for milk. It clearly does. So which theory is right? Honestly, none of them fully closes the case. The geometry theory explains why some species trigger the response and others don't, but it can't explain why the response sometimes deepens into something that looks a lot like attachment over time. The social efficiency theory explains why tolerance might be evolutionarily useful, but it doesn't explain why some animals go far beyond mere tolerance into active nurturing, feeding, and defending. And the ancient circuit theory explains why the trigger is so blunt and universal, but it doesn't explain why, in humans especially, it can expand into something that looks less like an accident and more like a choice. What we do know is this. Somewhere in the mammalian brain, and in at least some bird brains too, there is a circuit that fires the instant it detects a certain shape. Round face, big eyes, soft proportions, high-pitched distress. And when it fires, something ancient overrides the ordinary rules of survival, hunger, and threat. It doesn't ask what species it's looking at. It just responds. Which brings us back to that leopard in the tree, holding a baby baboon against her chest until sunrise. Nothing about that moment made sense by the ordinary logic of predator and prey. She had no reason to protect it, no reason to keep it warm, no reason to let the sun come up before deciding what to do. Maybe she was just following a signal 300 million years old, one that fires the same way in a leopard's brain as it does in yours when you see a photo of a puppy. Or maybe, and this is the part that should genuinely unsettle you a little, maybe something in her actually cared. We don't have a way to know which one it was, but she held on anyway.